We know that when x equals to 0, y equals to 1. So we can know the coordinates 0, 1. On the x and y axis, x0, when x0 is equals to 0, y0 is equals to 1. And we know that dy dx is the gradient of the tangent line, right? So assume the tangent line is here in this direction, and we move x0 to the right by one step. The step size is 0.1 to x1, and we can get y1 on the on the tangent line. So we know these 4 points. And to know the equation of this tangent line, we use y1 minus y0 is equals to m times x1 minus x0. And rearrange the equation, we get y1 is equals to y0 plus m times x1 minus x0. And this m is the gradient of the tangent line. And dy dx is also the gradient, also tells us the gradient of this tangent line. So we can replace dy dx, this equation, like use dy dx to replace m. And for x1 minus x0, we know that x0 to x1 we use 0.1, we moved 0.1 units. So x1 minus x0 we'll know that is 0.1. It's h. So we use h to replace this. So we get the equation y1 is equals to y0 plus h times dy dx. And the general equation is yn is equals to yn minus 1 plus h times this equation. Xn minus 1 squared plus 1 over yn minus 1. In this case, right, yn is y1, and y0 is yn minus 1. And my ODE, I got my answer is 1.91485.
We have the equation yn is equals to yn minus 1 plus h times dy dx. So when n is equals to 0, my x0 is equals to 0 and y0 is 1. We can know from here. This is given. To find y1, I use the equation y0 in d4 plus a4 is my h times c4 squared is my x squared plus 1 over d4 over my y. So dy dx is this equation, x squared plus 1 over y. To find y2 is the same. We use y2 is equals to y1 plus h times dy dx. So my y2 is y1 is my y1 1.1 in d5 times a4 is my h, and times c5 squared, my x squared divided by d5 is my this y. This is y1, and I get all these values, and I calculated this for 10 times 0, like n from 0 to 10. So I get my x from 0 to 1. And to find when x equals to 1, y is equals to, from here is 1.91375. And we can tell from this graph that as the x increases from 0 to 1, y is increasing from 1, in this case 1, to approximately 2. But the value is 1.911. This is like approximately 1.911. And my approximation error is I use the ODE method to calculate. The actual error is 1.91485 minus this value I get from Euler method to get approximation error 0.0348.